Good morning and welcome back. So today we're looking at part 3 of the University of Helsinki's massive open online course. My name's Duncan and we're going to have a look at discovering errors, working with lists and arrays, using strings in a bit more detail, and then summarising everything that we've learned. So let's have a look at discovering errors. So today we're going to look at knowing the term perceptual blindness and can learn to recognise essential and non-essential information with practice. So by the end of this section, we should know the term perceptual blindness and that we can learn to recognise essential and non-essential information with practice. Know ways to comment code and understand the importance of variable names on the readability of your code, and know the concept print debugging and know how to search for errors in the source code by printing. We've so far been practicing the fundamentals of the language, such as variables, conditionals, loops and methods. Let's now move on to look at some of the factors affecting the understandability of programs and how errors are found. Programmer blind to their own code. A programmer often becomes blind to their own code. Let's familiarise ourselves with this effect with the aid of the short video below. Count how many times the white-shirted players pass the ball between each other. The video contains instructions in English. Have a watch of this, it is quite interesting. Before we move on, I'll pop the link in the comments below as well, just so that you don't have to come here if you're not already on here. There's something else that also happens in the video that may go unnoticed at first. This effect is known as perceptual blindness and is explained by the fact that we focus on a specific task. Our brains tend to filter out information that is irrelevant to the task. However, we don't always know what information is essential and what is not. An example of this being when we study. Concentrating on a specific part of study exercise can lead to relevant information being filtered out. Fortunately, applying oneself to a given task lessens the occurrence of perceptual blindness. In other words, practice develops one's ability to distinguish between relevant and irrelevant information. One way in which perceptual blindness manifests itself in programming practice is when we concentrating on a specific part of a program draws attention away from seemingly correct yet erroneous parts. For instance, while inspecting the correctness of a program's output, a programmer may fixate on the print statements and mistakenly neglect some aspects of the logic. Likewise, a programmer may focus on the most complicated aspect of the program featuring a loop, when in fact the error lies somewhere else completely. An example of this is the program below, which is used to calculate the average of user inputted values. It contains an error, and when searching for it, the loop is typically the first target of focus. So, I wonder if we'll be able to spot it. Or we might have to run it to see where the error is. So, we've got scanner equals new scanner system.in, int value isn't sum while true, int value equals next line. I couldn't spot it. Let's see if we can find it though. So let's open up our NetBeans. You guys may have noticed actually that the if you have NetBeans installed as well, and if you're using version 8.2, that the plugin store has stopped working on NetBeans, and I believe that's because NetBeans 8.2 is the support is stopping for it. So if you're having trouble with it, that could be why. So what I'm going to do is just delete this here out of our main. There we go, and then I'm going to post this code in. Let's do our scanner import. Let's give it a run and see what happens. Provide a value, a negative value ends the program. If sum equals 0, I don't know what the error is on that. System out the average of the values. How bizarre. Maybe they'll tell us a bit later on. A bug still happens to remain in the program above. What kind of input can be used to find it? In the options below, the character N corresponds to a new line that is achieved by pressing enter. Select the correct answer. Bug still happens to remain in the program above. What kind of input can be used to find it? In the input below the character n corresponds to a new line. Okay, let's do a bit more testing then. Okay, that seems okay. So one of the examples they did was minus n followed by a backslash, n, which actually would fail anyway because it's a string. Let's have a look. So -1, that's fine. 6, and then n minus 1. I wonder if they mean because it's breaking when we use a string in there. Let's have another go. Let's just see. So 6 and then -1. Average value of 6. And the last one was 0. And then a -1. So maybe that's why, because it doesn't hold a value. I wonder if that's the bug because it prints out twice, perhaps. Let's try that one. Oh, perceptual blindness is something that cannot be eliminated completely. However, there are ways by which a programmer can lessen its effect. The first one being taking breaks, which require that work is begun early. Code comments, proper naming of things, and debugging prints are all additional examples of things that are also helpful. Comments have many purposes, and one of them is explaining how code works to oneself when searching for bugs. The execution of a relatively simple program is described below through the use of comments. So all of these here, so the / and the star is a multi-line comment, and then the double / is a single line comment, but you can use it multi-line as well. Okay. Comments have no impact on the execution of the program, i.e. the program works in the same way with the comments as it does without them. The comment style displayed above, that is intended for learning purposes, is, however, too elaborate for real development, where the goal is for the source code to be self-documenting. So there's a guy, famous programmer called Robert Martin, or Robert C. Martin, and he's known as Uncle Bob. And he has done quite a few actually he's written quite a few books actually which are worth a read, but he also does YouTube videos as well which are worth a watch. They're quite long but it is interesting, and he talks about commenting code, and basically says a similar sort of thing here, that good code or clean code should be self-explanatory and you shouldn't need to comment it, which may be true if you're in industry, but I think for what we're doing and the level that we're looking at, you can put as many comments on as you want. This means the functionality of a program should be evident from the way classes, methods, and variables are named, which again does, makes perfect sense. So if we go back here, if this class, Advanced Astrology, was called Class 1, that doesn't really give us any sort of information. And I know that Advanced Astrology doesn't really tell us what it's going to do, but we can probably guess it's going to be something to do with some sort of astrology. Then we see this method called print stars, which is again better than the name method 1. So before we've even read the code, we've got an idea that it's going to be some sort of output, and potentially something to do with stars. So by naming your methods, classes and variables appropriately can make your code easier to read and understand. Actually, I'll just quickly show you how to do comments as well. So we normally do the single line comments, and it's just a double /. When I do multi-lines, I tend not to use the / and the star, only because I find it easier to select a few lines and then press Control and / on your keyboard, and that will give you multi-line comments. So this means the functionality of the program should be evident from the way classes, methods and variables are named. The example can be commented out by encapsulating the code into a properly named method. Below are 2 examples of methods that do this. One of the methods is more general in its purpose compared to the other. The more general method assumes, however, that the user knows which of the 2 parameters is assigned the higher and the lower values. So here we've got our first method, so print values from 10 to 1, and then here is our second one. Okay, so one takes argument and the other doesn't. Searching for errors with print debugging. One required skill in programming is the ability to test and debug code when searching for errors. The simplest way to search for errors is to use so-called print debugging, which in practice involves adding messages to certain lines of code. These messages are used to follow the flow of the program's execution and can also contain values of variables that live in the program. Let's inspect the program already familiar to us from the previous question that was used to calculate the average of non-negative values. So, had the program contained an error, print debugging could have been used to unravel its functionality by adding print statements to the appropriate places. The example below contains one possible example of a program containing print debug statements. So here we've got our regular while loop, and then we've got a few extra bits added in. So here we're looking to see what values is as we enter the loop, just to make sure that the value is correct. And then we've also got here a print inside the other loop, just printing out to see what the negative value is again, but also to make sure that it's entering the if statement and the while loop as well. It could be that your conditional logic, this true, could be false, and it might be that you've put a systemout.print here and it's not actually even reaching inside the loop. Okay, so down the bottom you can put that the soup has been exited. Did I say soup? Sorry, the loop has been exited, and that will show that it's either processed through the loop or the condition isn't true and it's skipped over the loop, missed it completely and gone to this section here. And then we've got this final update of the values and the sum as well. So print debugging can be really, really useful, and personally it's something that I use quite frequently. When a program is executed multiple times with appropriate inputs, the hidden error is often found. Coming up with relevant inputs is a skill in its own right. It's essential to test the so-called corner cases, i.e. circumstances where the program execution could be exceptional. An example scenario would be one where the user does not enter a single acceptable value or enter zeros or very large values, or so they're classed as extreme numbers. So for this bit, all you need to do is have a look at this code here, have a read of this, and then answer in here what you think the problems could be. Okay, so I'm going to quickly fill mine out, and then we will carry on with lists. So that's this section done. We looked at discovering errors. There are other ways that you can look at errors as well. NetBeans has quite a good debugging suite contained within it as well, and there are test classes that you can implement too and make use of as well. Like I said, I quite often use print line debugging because it's nice and quick and easy, and it can give you a quick answer as to whether your loop, for example, is working or isn't. So I quite like using those for my personal coding. Next time we're going to be looking at lists, and then after that arrays. So these two are going to be really interesting because they're about storing data. So until then, happy coding, good luck, and I will speak to you all later.